Okay, so I wanted to do a quick video. Quick. I don't think it'll be quick because I have 6 different slides, but kind of going over what we've done so far in this unit about transformations of parent functions. We did last class, we talked about translations of the parent functions, and especially in the world of, in the parent function, the family of the quadratic function. Okay, so this unit does this. In many programs, it does the same thing. It introduces a transformation using a specific family of function, but you do have to understand that these transformations work for any type of function, whether you are working with trig functions, absolute value functions, exponential functions, like those type of transformations are represented the same within the equation. Now the graph is obviously looking different because the parent function itself is different. Okay, so now we're gonna go back a little bit over the reflections of parent functions, and we will mix it up in the last few slides with the translations as well. That's when it becomes a little tricky, because introducing each transformation on its own is quite simple, but as soon as you start mixing it up, there's some order in which you have to do it, depending if you're graphing or writing the equation from a graph. We will end with that today. My last slide will be about that. Okay, so first of all, let's take a look at the parent function of the square root function here, which is our y equals square root of x. I'm not going to spend too much time on that because it seemed like it was something that was quite understood during the lesson today. I will spend a little bit more time on the last 3 slides. Okay, so I laid out the key points here. And how do I choose 0, 1, 4, and 9? It's because remember the x are my input values, and I picked those points because they look nice. Okay, so square root of 0 is 0, square root of 1 is positive 1, square root of 4 is 2, and square root of 9 is 3. It's off the graph, but you can see where we're going with this. Now somebody asked me in the class today, it's like, wait a minute, but why is it that we don't have the positive, right, and negative value here? I will tell you, look at this. You are given the square root. The equation is a square root, and it has a positive here in front of the x for the root for the moment. So what I'm asking for is the positive square root of x. Okay, so this is how you kind of have to look at it. Okay, you get a positive and negative answer when you're solving an equation where you have to undo a square. You see here, to undo the square, I have to square root both sides. I created the square root. Hence, I don't know if it was 5 or negative 5. But in this particular case here, your root is already given to you. So you already know it's a positive root. Okay, so this not the same rule that applies here. Okay, so let me erase this. So I have my parent function of my square root function. Remember, when you're graphing a graph that's not a line per se, so you just have to put at least 3 key points for the square root function. It's 3 key points, and connect them the best you can. Okay. Now let's go to the next slide and talk about our first reflection. We are going to create our horizontal reflection, but it's also about the y-axis. Careful, it's the other way around. Because if I am taking my parent function, right, of my square root function, and I'm adding a negative here, what is it really that I'm doing? Well, I'm telling you to what's happening here is I'm inputting a value here. Can I input a positive? Well, 0 is fine. It gives me 0. But can I input a positive value? Well, let's try it. Let's say I input the value of x equals 4. Let's see what happens. I get y equals square root of negative 4. Meh, doesn't work. I mean, it gives me an imaginary solution, which in this case is not useful. So I have to kind of start thinking about this, but wait a minute. How can I fix that problem? Like I'm inputting right now, right? I'm inputting some positive values and it doesn't work. So let's try to do something else. Let's try a new strategy and let's input some negative values in here and see what happens. So I'm going to input a negative 4 here. You see what just happened? Y equals square root of negative negative is 4. Ah, there you go. We get a positive 2. So again, really what's going on here, I know you noticed that when you graphed it during class today or yesterday, but the thing is right now you understand more the algebraic part of it, okay? So what is just happening here is I'm going to input a negative 4 here inside, but it's going to spit out a positive. Same thing with negative 1, right? It's going to come out as positive 1. And I just created my reflection about, I'm just going to get a different color about the, whoops, that was not really nice, sorry. I'm just going to try to do it better. Okay, so the reflection about the y-axis, about this axis. The mirror is the vertical line, but it's a horizontal reflection because it's moving this way, okay? So be very careful. Again, as a translation, it's an opposite operation. Okay, so let's move on to the next slide. Now we're going to do our vertical reflection. Same thing, we're not going to linger too much. The only difference with this one is that, remember, some of you like to keep the vertical transformations with the y, and some of you prefer to leave y alone. Totally fine with me. Also, remember, we talked about having it as a division. And again, right now, I know it looks weird. Sorry, I shouldn't have put that because it doesn't make sense. By the way, I should have had that too on the slide before. You could have had it like this as well. Square root of x over negative 1. Careful that it needs to be inside the grouping symbol. And again, in the next lesson, you're going to see why I really emphasize on this method. If you still don't want to use it, it is your choice. I really don't mind. Just make sure you don't make any mistakes. But since there's no transformations right now, I usually just keep it there, okay, where it belongs. So again, my parent function, right? You need to learn those by heart. So far, we don't have that many. So don't worry too much about that. So just remember what they look like and their key points, obviously. Okay, now, so really what's going on here is that I'm inputting a regular positive value, right? 0, 1, 4, and 9. And what is going on here? I am putting my value, well, 0 squared is 0. But if I'm inputting the value of square root of 1, I get 1, right? But there's a minus here. So it turns into a negative 1. So my output becomes negative. My input is positive, but my output is negative. That's why it's been reflected on over the x-axis. You see here my x-axis. Okay, that's why my graph is going to look like this. Good. Next slide. Now we're going to get our first example. Now that we got our two reflections, and just remember, if you have a reflection on both axes, it turns here, right? It flips from here vertically and then horizontally, or the other way around. It doesn't matter. Okay, so now our first example, we do have to kind of look at it first. And I write it the two different ways because I don't know which way you prefer. So I'm getting to the habit of getting always the two answers, okay? So now what's really going on here, I didn't put there's no reflections, okay? So let's just look at some shifts right now. So we're taking our parent function that usually is here. We've drew a lot, so hopefully it's starting to stick in a little bit. So we are graphing it. Let me just see something. I feel like I'd like to have, okay, let's get it red. So we are moving our point of reference, right, our vertex of this square root function. We're moving it 1 unit to the right and 3 units down. 1, 2, 3. Here, you see? But nothing else has changed. Look at here. My first point usually happens 1 unit to the right and 1 unit up. So my next point will be 1 to the right, 1 up. And my next key point happens 4 units to the right, again from the vertex, and 1 unit, 2 units up. So 4 and 2 up, and then let's connect this. So you see, this is our final answer. This is a translation after a transition of this function after a 1 unit to the right and 3 units down. Nothing else happened, okay? So let's bring up the level of difficulty for the next one. We're going to do example 2. And you see these look a little crazier. And do you notice that right away, right off the bat here, I like to use my -1 under. When there's only a y by itself, it's okay. It looks kind of weird. But in this case here, I really, really, really urge you to try to start doing this. You will understand why it looks better. But this could also be written as minus like this, y plus 3 equals, there's a minus there, x minus 1, like this, okay? So, remember, be very careful with the way you write this. Remember, and I will talk about that again on the last slide today, when you're writing the equation of a graph, you always write the translation first and then the reflection. So the reflection has to affect the translation as well, meaning visually you don't see it, but that negative sign here, you don't go like this. You don't go like, let's say you have a y. You don't put the y first and then add the 3. It's the other way around. You add the 3 first and then the minus affects it. Okay? So just keep that in mind. So let's see what's going on with that graph. I told you, and I'm going to repeat that on the last slide. You have to reflect first, and if you're graphing, and then translations. Well, okay. So I know this is a rule, but if you do have a good understanding of what's going on here, it's okay to do the other way around. But I will not. I will follow the rules because I'm a rule follower, and I will do my reflections first. And look, I have 2 reflections. I have about the x-axis and the y-axis. So I know that my parent function is first reflected this way. Good? Now I've done my reflections. Now I'm going to do my translations. You see, that's not that complex. It's moving 1 unit to the right, right? Because careful, it's changing the signs. I'm going to use a different color for the graph. I'll get the red again. So it's moving 1 unit to the right and it's moving 3 units down. 1, 2, 3. So you see, and again, don't forget it's a unit. It's 1, 1 and 2, 4. You see? Now remember, it's okay, it's totally fine if you decide to move first, but remember the lines of reflection, whether it's the x or the y-axis, will be moving with the vertex. The vertex will always be attached to the lines of symmetry. So if you decide to do the translation first, it's okay, but it's reflecting about those 2 dotted lines that I put there. Because I have seen that happening. I want to show you what I've seen happening right now. Okay? And remember that everything that I'm doing right now for the next minute or so is wrong, is incorrect. So I've seen some students going, okay, I'm going to move first. So I'm moving 1 unit to the right and 3 down. And they have their function moved, right? And then they say, oh, and let's reflect about the y, and then there's a reflection about the y and the x-axis. So they go and they reflect above here. You see what's happening there? Okay, I don't know if you guys realize what I just did, but look. They reflected about the x-axis because they thought that was the rule. It is untrue. Because now if you decide to move first, I shouldn't do that. Sorry. My line of reflection is moving along with with the vertex here. Okay? So just keep that in mind. Okay, quickly, last, the order in which you perform your transformations. If you are writing an equation from the graph, let's say you're given a graph. I'm giving you the graph and I'll say write the equation from the graph. Always write down, first of all, identify your parent function, whether it's square root of x or x equals x, y equals x squared, or y equals absolute value of x. It doesn't matter. And then always perform first, always insert your translations first. And then you insert your reflections. And I want to write dilations because we're going there next class, okay? They go along together. So meaning you'd have your parent function here. Let's say you have this one. You would insert y minus 4. I'm making this up. It's moving 4 units up. And this function is moving x plus 2. It's moving 2 units to the left. And then let's say there's some reflections in there. Then you see the reflection affects everything. I'm just making this up. There could have been just a reflection under the y or under the x. Okay, so it comes after. Now we talked about that in the slide before. When you are graphing now, it's different. You're supposed to be, again, identifying your parent function, identify where it goes, what's my original key points of that parent function. Then you perform your reflections / dilations, right? And then you translations. But remember that this one could be somehow interchanged. If you do remember that if you decide to translate first, the line of reflection does move with the vertex or the key points, okay? So keep that in mind. But if you really want to do it the way it's supposed to be, it's reflections, dilations first, and then translations. We are going to get to a number at some point, a way of performing transformations on of y equals f of x graphs, meaning graphs that we don't know the parent function of. Then it's going to be imperative that you use this order. In this case, you will not be allowed to get away with it, okay? But it's coming up in a few classes, so don't worry about this too much. Well, long video. I hope it helped a little bit. I hope you took notes. And if you do have more questions, please show up to Opportunity Today. I'll be happy to help you.